Welcome to today's lesson on the rates of chemical reactions. In this presentation, we will explore what rate of reaction means, how to measure it, and how to represent it on graphs. The rate of a chemical reaction refers to how quickly reactants change into products. We can measure it either by the speed at which reactants are used up, or by the speed at which products are formed. Some reactions are slow, some are moderate, and others are extremely fast. For a slow reaction, consider rusting of iron. This process can take years or even decades to complete. A more typical rate is the reaction between magnesium and an acid. This produces a gentle stream of hydrogen bubbles over time. At the other extreme, we have very fast reactions such as fireworks explosions, lighting of matchstick. These reactions take place in a fraction of a second. To measure the rate of reaction, we either measure how quickly the reactants are used up, or how fast the products are formed. We are going to investigate the rate of reaction between hydrochloric acid and limestone chips. In this experiment, we set up a conical flask containing limestone chips. Hydrochloric acid is added, and the flask is connected to a gas syringe using a delivery tube. When the hydrochloric acid reacts with limestone, carbon dioxide gas is produced. This gas travels through the delivery tube and is collected in the gas syringe. To measure the rate of reaction, we record the volume of gas collected in the syringe at regular intervals. For example, every 30 seconds for a total of 3 minutes. Finally, we calculate the mean rate of reaction. Suppose 60 cubic centimeters of carbon dioxide gas was collected in 2 minutes. 2 minutes is equal to 120 seconds. So, the rate equals 60 divided by 120, which gives 0.5 cubic centimeters per second. There are 2 ways to express the rate of reaction. It can be written as the amount of reactants used divided by the time taken, or as the amount of products formed divided by the time taken. Let us consider an example. In this reaction, magnesium reacts with acid to produce hydrogen gas. Here, 180 cubic centimeters of hydrogen gas was produced in 2 minutes. The first step is to convert the time into seconds. Since 1 minute equals 60 seconds, 2 minutes becomes 120 seconds. Next, we apply the formula. Rate equals 180 divided by 120. This gives us 1.5 cubic centimeters per second. Now let us consider another example. 3 grams of magnesium was used, and it took 4 minutes for it to be completely used up. Again, the first step is to convert the time. 4 minutes equals 240 seconds. Next, we divide the mass of magnesium used by the time. That is 3 divided by 240. This gives us 0.0125 grams per second. We can clearly represent the changes in a chemical reaction by using graphs. If we plot the mass of reactants against time, the graph starts at a high value and steadily decreases as the reactants are consumed. At first, the line is steep because the reaction is very fast when many particles are available to collide. Over time, the slope becomes gentler, showing that fewer collisions are happening and the reaction is slowing down. On the other hand, if we plot the volume of product formed against time, the graph begins at 0 and rises sharply at first. Finally, the curve levels off into a plateau, indicating that the reaction has stopped because all the reactants have been used up. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time to answer the question. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concepts effectively and enjoyably.